So in this video, we're going to talk about how to program your robot to do autonomous routines. So last video we talked about how to set up these devices and map your buttons to the controller and stuff like that. So for the autonomous part of the code, I'm going to delete all this just for now. You can keep these actually, like with your autonomous code. This is all going to function only during driver control, because during autonomous they have electronics in the field to actually just disable your robot completely. So yeah, so in under events there's an option called when autonomous, and this is where you need to program your entire autonomous routine. And the nice thing about the vexcode v5, the drag and drop programming language, is it's exactly just Scratch. It uses the Scratch API. So there are these nice things called messages, and what you can do is actually like send out like signals in the program, like at different points of code, and when you receive those signals it'll do certain actions. So I'll talk about that in just 1 second. So for our autonomous routine, most teams decide to go with doing the rollers occasionally, or sometimes teams even decide to shoot. But it's going to be really difficult to get your robot perfectly aligned to shoot accurately. So I would refrain from doing that unless you guys have program like vision sensors or GPS sensors to aid your robot with navigation. So under one autonomous, like let's just say I'm going to drive backward for like 100, or let's just say 100 millimeters, right? It's easier to measure, and I just want to move back just a little bit so the robot will go hit the rollers. And then now I'm gonna go down to motion, and then let's say I want to spin my roller motor forward for, like, let's say, I don't know, like 100 degrees. So what this is going to do is actually turn your roller wheels. So while this is making contact with the rollers, it's going to turn that wheel and turn the roller to your team's side. And then I guess you can repeat this. Now you can make your robot turn a little bit, and then, like, let's say 90 degrees, and then go backward again and do the other rollers. And one more thing I want to say is these turn values, although like you specify 90 degrees, they're not always 100% accurate. So you might have to mess around with it to get the turning perfect. For example, if you want to turn 90 degrees, if you want your robot to turn 90 degrees, which is 1/4 of a full circle, you might want to play around with the values, see which gets you the most precise and accurate result, and then use that value. It may not be 90 degrees. Sometimes it may be 75 degrees. Sometimes it may be 105 degrees, but it might be different for every team is what I'm trying to say. And again, the thing is, there's no feedback coming from the motors. So what's going to happen is you have your robot, you tell it to turn, but you don't actually check if it's turning. There's no active feedback control. And there are ways to program this with sensors, but we're not going to get into that right now since we're just looking at the very simple parts of the code. So if I want to turn 90 degrees, I'm going to have to do some trial and error. And let's say 74 is the value that works for me. I'm just going to put that in, but knowing that it'll turn 90 degrees approximately. So now I have to turn right, and then let's just duplicate this whole part. Drive reverse for, let's say, like 300 millimeters this time, because we want to go back a little bit more. And then spin roller forward for 100 degrees, and then let's say that's where we want our autonomous to end. We don't have to do anything after that. We can just wait here. So I would just put like a stop driving block and a stop roller block, just to make sure that all the motors have come to a full stop, so you don't waste battery or heat up the motors unnecessarily. So in the actual game itself, what's going to happen is, because your controllers are like directly connected to the field itself, once 30 seconds are up, your controller will automatically kick in. This block right here is pretty much useless, I would say, because every one of your actions in your driver control will be mapped to your controller, and so you don't want your robot to do anything while it's not under while you're not giving it active input. Again, when you get into more complex programming, let's say for example your vision sensor, you might be constantly looking for images and stuff like that, and when you put that type of stuff in when started, what it's going to do is actually um, keep it going continuously throughout the entire program. If you put any controller mapping in here, it won't work during autonomous. That's just how like they control it. But yeah, that is how you program autonomous. And when you connect your computer using a micro USB cable to your controller, and your brain is connected to your controller through radio, you can actually just download your program to the controller, and it will download it to the brain too. So yeah, now you guys can program an autonomous routine, and you can change this up. So for example, I can just say this is like the left side or the right side autonomous, and I could change this into different slots. So for example, if I'm on the blue alliance, I might want to turn the rollers in opposite directions. So I would just rename this project and save it to, I don't know, like slot 2 or something. But yeah, feel free to reach out if you have any questions. In the next video, we'll look into how we can use more advanced sensors and methods to control your robot.